Hi, I'm Peter Prevost, and this video is about the Denote Explorer package, which is part of Emacs Writing Studio. This is a package that helps you to explore your collection of Denote nodes and other files, and it contains four types of commands. First is a series of commands for descriptive statistics. Then there's a set of commands for taking a random walk through your digital garden. There is the Denote janitor to help you clean up the place. And last but not least, there's extensive functionality to visualize the interrelationships between the different nodes in your collection. But let's stop talking and start doing. So in this demonstration, I'm going to follow the Denote Explorer manual, which you can access with Ctrl-H, capital R, and then type Denote, and choose the Denote Explorer manual, hit enter, and there we go. So the Denote package by Stavro provides extensive functionality for creating and retrieving and managing and linking files in plaintext, markdown, org mode, but also lots of other file types, which in this context within Emacs Writing Studio we call attachments. Now I wrote the Denote Explorer package to help me manage my burgeoning collection of Denote files. So we'll step through all the different functionality and give you an idea of what's possible. So first are the functions related to descriptive statistics. There might come a time where you think, how many nodes do I actually have? Well, to find that out, there's the Denote Explorer count nodes command, and it does what it says on the box in the echo area at the bottom of the screen, and now it tells me that I have 2158 nodes. So that's org mode, markdown, or text files, and 1239 attachments. So that's files of any other type. They could be photographs or PDF files or anything. So that's good. There's also a function to count keywords or file tags or categories, whatever you like to call them. It says here in the echo area that I have 7,124 keywords, of which there are 180 distinctive keywords. So that's interesting. But, you know, as I say, a picture says more than 1,000 words, so a graph says more than 1,000 numbers. And there is a great package built into Emacs called chart.dl by Eric Ludlam, and I've leveraged that to visualize some aspects of our Denote collections. So we search for the bar chart functions. The first one I like to show is the file types function. Now what this does, it counts all the different extensions in your Denote collection and then visualizes them as a bar chart using the chart.el package. You see that most of my files are related to org mode files. These are the nodes, and then there's all the other stuff. I can also exclude the Denote files, Denote nodes from the count. So that's exclude any org mode, markdown, or text files, by first using the universal argument Ctrl-U, and then run the same function again. So now it will do that same count, but this time without any nodes. So these are only the attachments, and it tells me I've got 1,239 attachments of all these different types. So the vast majority are PDFs, which are scanned documents and invoices, etc., that are emailed to me. So there's other bar chart functionality. We can also visualize the keywords. So Denote Explorer bar chart keywords first asks me how many keywords do I want to visualize. So let's say I want to visualize 15. Now it counts all the keywords and gives me the top 15 keywords and displays that in a bar chart. So now you get a good insight into my diverse interests. So there is these are all the different topics. You see that BIP is a very common keyword that I use. There are some regular expressions described in the manual that you can use to exclude different keywords from these graphs. So this is a graph of keywords. Next bar chart in the descriptive statistics part is a timeline. Now I use Denote also to store historic document. I'm in the process of scanning a lot of old documents, and the oldest document in my collection is from 1370, which is a mortgage document of the house I was born in back in the Netherlands. So if I would use the Denote date, it would create an ID that has the timestamp of the date that the scanned file was created. But I manually created these timestamps and actually moved it back in time. So as you shall see now, my bar chart of the Denote timeline starts in 1370 and goes all the way up to 2025. So that's a way to sort of explore the basic statistics of your Denote collections. Creativity often comes out of coincidence. So why not create some functions that actually simulate some coincidence so that you can take a random walk, so a random stroll through your digital garden. And there's 4 different ways of doing this. First is the Denote Explore Random Note. Random note. So once I hit enter, this function will take me to a random node at my collection. So it'll be interesting to see where it ends up. Good, so this is a little philosophy note that I wrote. Let's not worry about the content for now. So I jump to a random note and I might think, oh, that's interesting. I can't remember writing that note. I actually can't remember writing that note. So I might want to explore further. So the next thing I can do is to jump to a random node that has the same keyword. So the Denote Explore Random keyword, what it does is there's only one keyword in this previous node, so it jumps to a random node that has the philosophy keyword. If I now run this function again, it first now asks me, which keyword do I want to jump to? Because this node has 3 keywords, BIP, management, and philosophy. So let's jump to a random management node. So I can sort of randomly jump through my digital garden in this way. There's some other random walks functions. There's Denote Explore Random Link. So when you're inside a node, it jumps to a random link within a node or a random node that is linked to that node. So that's a way of jumping, I guess, through the network of nodes. You can also jump to a random regular expression. So Denote Explore Random regex. I can, for example, give a regular expression that says, give me a random node that has Emacs as a keyword, and because this is a regular expression, I can use a dot star and also EWS. Now the keywords have to be in alphabetical order, or you have to write a much more complex regular expression, but now we'll search for all the nodes that match this regular expression, and then from that sample, we'll pick a random node. So there we go. So these are the functions that are available for random walks. Again, there's a regular expression variable that you can use to exclude specific files from your random excursions. These functions only jump to a random node. If you want to include attachments, so that's anything that's not an org mode or a markdown or a text file, you press Ctrl-U and then run that function, so the universal argument. And then it will also include PDF files and so on. So those were the random walks. Once you have a large collection of nodes, you might want to clean up and repair things. And therefore, there's a set of functionality called the janitor. Now, a janitor is somebody who maintains and cleans large buildings. So why not have a janitor for your Denote collection? So the first set of functions relates to duplicate nodes. Now, the Denote package itself will actually ensure that duplicate nodes can't exist. So duplicate in the sense that they have a duplicate identifier. But as you saw, I use Denote to also use timestamps that go way beyond the history of computing. So I often manually add timestamps because I need to make them up, right? I don't even know exactly sometimes what date a node was taken or a document was created. So duplicate nodes can exist. Another reason why duplicates can exist is when you export an org mode file to, say, HTML or PDF, it actually creates a file with exactly the same file name but a different extension. So there are 2 functions within Denote Explore to explore duplicate nodes. The Denote, explore, identify duplicate nodes. If I run this, the system will start searching for duplicate nodes, and it opens up a read-only buffer, and we can jump to this buffer here. And there are some hyperlinks. So here's a node, and happen to know this is a duplicate because I exported this file. So here's the Steven Toolman file, and it's the org version. And there is also a HTML version. So I could, for example, then delete that HTML version and it will disappear. Now, if I use the universal argument Ctrl-U and run this function to search for duplicate nodes, it will automatically exclude any duplications caused by exploitation. But let's delete this file anyway, because I don't really need that HTML file. So here is one more that is an actual duplicate, because what have I done? Let's go back. Okay, so I can now follow that link. Ctrl-C, Ctrl-O opens that file, and now with Ctrl-XJ I can jump into the directory editor, and here I can see the duplication was created. There's another function where I can go to Denote, explore duplicate nodes, and I jump directly into the directory editor and can edit things accordingly. So there's a very nice little function which is Ctrl-X, Ctrl-Q, and now I can manually change that file type. Ctrl-C, Ctrl-C, and now the duplication has disappeared. So these are some functions to manage any duplications that might appear in your duplicate nodes. Sorry, in your node collection. The next function within the Denote janitor is a function to find missing or dead links. So dead links might appear if you previously had a link to a file, but then the file disappears, or you accidentally corrupt the link and then the linkage no longer exists. So Denote, explore dead links, jumps through all your files, and it finds any links. So I can now go through this buffer here. It says one dead links identified, and I can follow the hyperlinks to repair this issue. So Ctrl-C, Ctrl-O. I now get a pop-up from Emacs where I want to execute the eLisp, because this link actually creates a little bit of Lisp, because if I say yes, it jumps straight to that file and the suspected link, and then I can choose to repair that or not. If you configure the org-link eLisp conform function, then you don't get this pop-up. So to give you an idea what's in this link, it says here eLisp, and then the eLisp calls the Denote explore review dead link function to the explore and jumps to the relevant location. So that's some functionality to find missing links. There's also a set of functions to manage your keywords. Now keywords, file tags or categories, they have a specific purpose. They group nodes and attachments together. So there's some ideas here, right? That basically each keyword should have at least 2 nodes in it, otherwise it's not much of a category. We could also argue that every file within our system should have at least 1 keyword. So there are 2 functions that you can use to explore that concept. So Denote explore 0 keywords creates a list here of all the files that don't have any keywords, and then I can open these up and decide to add a link or not. There is also Denote explore single keywords. This provides a list in the mini buffer of all the keywords that are used only once. Now, why could a keyword genuinely only be used once? That's of course when you just start to build up that category. Also, sometimes this is a way for me to find typos in keywords, which leads me to the next functionality, and that's a function to rename keywords. You might change your mind about what a keyword should be called. You might want to change the bibliography keyword, for example, or you've mistyped the keyword and you want to correct this. So Denote explore rename keyword first asks to pick an existing keyword. So let's pick my testing keyword here, and instead of testing I want to call it demo. Okay, very good. By the way, if I choose as a new keyword an empty string, then the testing keyword will be removed. If I hit enter, the package will now search for any instances where the word keyword testing is used and now ask me if I want to rename this, and I can say yes, and I get some confirmations here. And that was the end of it. So this is a function to rename keywords. Within the Denote package, the metadata, and this is its main source of power, is in the file name. The file naming convention, albeit very strict, is an extremely useful way to find information. Some of the metadata is also in the front meta. But what if those two are not synchronized? Perhaps you want to make sure that they're all synchronized. So now what I'm going to do, I'm going to create a little use case here in this demo node. Create a new title here, which is not in the keyword. So Denote explore sync metadata. It first asks me to make sure that I save all the Denote files that are currently open. I say yes. And now it has found this file and it says, do you want to rename this using the front meta as the source of truth? So I can say now yes. And there's another one as well. That's a node we created earlier. Let's say yes as well. And now you'll see that also the file name down here has the word synchronized in it. So that's a function to synchronize all your metadata with your file names. Now, for the last part, which is probably the most exciting part, is we're going to visualize our Denote collections. There are several ways in which Denote files and attachments can be related to each other. First of all, they can form part of the same category. They can be related with a signature through a sequence. They could all have a similar regular expression, for example, the word Emacs, or they could have hyperlinks between them. So these are all the different ways that we could explore these nodes as a network. So what does this mean? A network has nodes, and the node can be a node or an attachment. And these nodes are connected by edges. Now, an edge can be a link, but it can also be a joint category, a joint regular expression, a sequence, and some other ways of relating nodes to each other. Now, the Denote Explorer provides 4 types of network diagrams to explore the relationships between your thoughts. And I'm going to demonstrate all 4 of these to you. So first, a community of nodes. A community of nodes is a group of Denote files that share a common regular expression. So in the little plain text graph down here below, underscore Emacs, which is surrounded by a dashed line, that's the community of nodes that match the underscore Emacs regular expression. And then this graph will show all the hyperlinks between those nodes. In this example, there's also a file that has the Emacs keyword, but it links to a file with the Vim keyword that is excluded from this community. Now let's demonstrate this with a real example. So the Denote Explore network is really the only function you need to know, only one of 2, sorry. And we want a community graph. So here I can choose between the 4 types. So community. And for community, I need to enter a regular expression. Now it says an empty string to visualize all nodes. Because I have thousands of nodes with so many different connections, that is actually not a very useful thing. The idea of the Denote Explorer is to create a scalpel to analyze your nodes, not just splatter everything on the screen. So let's use underscore Emacs as an example. If I hit enter, the system will go away and start building a graph. And by default, this is visualized in the d3.js JavaScript functionality. So what we see here is a HTML file. And how is this created? The Denote Explorer analyzes all your nodes, creates a nested association list inside Emacs. That is, in this case, then converted to a JSON file, and the JSON file is embedded in a HTML template, and presto, this is the result. So we see here there's some links between nodes, but there's also a whole bunch of nodes that sort of live by themselves, right? So that's they're a bit lonely. the different colors relate to the different file types. If I hover on a node, it gives me some metadata. So this is an org mode file, which is about a Raspberry Pi CyberDeck. And yeah, this has an ID. It has a degree of 0. That means there's no links coming in or out. And it, obviously then also 0 backlinks. If I click on the link, it will open it up in Firefox. I have not been able yet to configure Firefox to actually open this back in Emacs, but that is a possibility. So these are all the org mode files, this orangey color. There's also a purple one, which is a plain text file. What we have here is an MKV, another text file, eList file, and down here. So if there is a PDF file or an image file, it will also provide a preview of that file. I have not written preview functionality yet for the text files. So maybe somebody can do this for me. And also PDF files are shown. Now again, same thing here. I can click on this node and then the PDF file opens if I want to read this document. Now all these nodes provide a bit of clutter. So there's functionality here to get some information. So click on the info button. You see here that this is a community network with the regular expression Emacs. There are 93 nodes, 31 edges, and the degree density is just a degree of the interconnectivity between the nodes. And 0.007 is very low. 0.15 is usually a nicely connected network. And there are 63 isolated nodes. So let's just hide these from view because that's probably a bit more interesting. There's a legend here for the different file types and also a graph for the occurrence of keywords. Labels within this type of graph only appear for nodes that have a degree of 3 or more, but we can manipulate this with this slicer here, and we can then also show all the different nodes. With the scroll bar, we can zoom in and out. So this is a d3.js JavaScript. Please note that this file does download a file from the d3gs.org website, but you can configure that if you want and use a local file. So let's go back to Emacs. So that's a community of nodes. The second type of graph is a node neighborhood. So what is a neighborhood? A neighborhood starts from a root node. So you open a node and then it looks at all the links one level deep and all the links in those files and all the links in those files, etc., etc. So to create one of those, we go back to the Denote Explore Network function. This time we chose a neighborhood. If I'm now in an existing node, it will use that as the root node, assuming it has some links. Because I'm not in a Denote file, it will now serve me a list of nodes that actually have links or backlinks. So let's use this architecture one as an example. Hit enter. Now I'm asked to enter a depth, and 2 is the default. I wouldn't go much higher than 3 because then, especially also in my case, but it depends on how your network is constructed. It provides so many nodes and so many edges that there's probably not actually a lot of information available in there. So let's use 2 as the default. So now there's 2 iterations, and again, Firefox will pop up here, and there is my graph. Same principles apply. There is some statistics here. There's no isolated nodes because we're starting at a node and we're following links, so there can't be any orphans here. And again, we can play with the label density, etc. So that is a node neighborhood. The third type is a network of sequences. So in the Tettle-Custom method, all the nodes get a sequence. So you might have a category 1, let's say that's Emacs, right? Then 1 equals 1 would be Emacs Writing Studio, and 1 equals 1 equals A is Emacs Writing Studio Denote, whatever it might be, and 1 equals 2 is another category. And you create this sort of parent-child relationship between your nodes. Now, Prod is actually working on some extensions within Denote to build this functionality, but I've taken a step ahead of this and just start visualizing these networks. So basically what that means, you need to choose a signature to start with. So if I go Denote Explore Network and I choose a sequence, and now will serve me with a list with all the signatures that are available. And what the system does, it just splits them up by the equal sign and then builds the relationships accordingly in parent-child relationships. So let's say I want to start at number 2. So that means that 2 is the parent, and then we have 2, 1 and 2, 2 and 2, 1, 1 and 2, 1, 1, 1, etc., etc. So now system goes through those nodes, and here is the relevant network. Now I need to do some work to actually display this as a hierarchical network, but you get the idea. So here's node number 2, and then it builds this network around it. Again, we can get some statistics the same way we had before. The last type of network that's possible is a keyword network. So here's the situation. You have a node, and this node has 2 keywords. So keyword 1 and keyword 2. So that means that there's a logical relationship between those 2 keywords because they appear in the same node. Then there's another node that has keyword 1, keyword 2, and keyword 3. So therefore, there's a logical relationship between these 3 keywords. They form what's called a complete network. And then, just to close the example, there's also keyword 3 and 4. They also appear in the same node. Now, what if you do that with all your nodes and look at all the keywords and then build relationships as such? And that's what a keyword network is. But it's a very different type of graph. So go to keywords. Now I need to enter a minimum weight. So the weight is what the system does. It actually counts the number of times these relationships appear. You've seen in the other graph that the size of the bubble is related to the number of ingoing and outgoing links related to the degree. And in the other graphs, the edge had a direction. There was an arrow with a little point on it. In this case, there's no relationship because the relationship doesn't go from keyword 1 to keyword 2, but it's bidirectional. But what we're counting here is not the number of links, but the number of times these links occur. And the minimum weight is just the minimum we want to visualize. So let's say that's 12. So now we get a network that shows all my keywords that at least appear 12 times together in the same node. So you see here that marketing and water closely relate to each other, and that has to do with the fact that my dissertation was about marketing of tap water services. Then we have management relates to, there's the BIP keyword, there's a regular expression to exclude it because the BIP keyword is just used for CTA Denote, so it doesn't really mean anything. But this is a macro way to look at your nodes and see what interests you have. The info button doesn't have a whole lot of stuff because there's not much point in the other statistics. And again, we can change the label density by doing this. So these are the 4 different types of keywords. Different types of networks that can be visualized. Section 4.5 explains how all this works, but also there's different ways of creating the output as well. So the default is d3.js, and there are some configurations that you can use. We can, for example, change the color scheme. You can also choose to point to another JavaScript source file if you don't like to use the one that's online. That's all described here in the manual. But there's also 2 other formats. If you have the GraphViz package installed, you can also export it as a GraphViz file, which is very useful because you can do it as a PDF file or a SVG file, which you perhaps can use in a publication. So let's demo this as the last step in this video. We're going to customize variable and Denote Explore. And we need the network format, which is currently set, as you see, at D3 JavaScript. There's the value menu, and let's change this to GraphViz. So this means you need to have the GraphViz software installed. What I can do now is I can regenerate the previous network. So there's another function, Denote Explore network regenerate, and it will use the same parameters as my previous version, If I hit enter now, but this time the output will appear as a as a graph.viz file. The text is a bit small, but you get the idea, and I could use this, for example, in a publication. There's a lot of other variables that you can use to configure how the output is displayed. Let's go to Customize Group. And then we pick Denote Explore, and here is all the different variables. And most of these variables relate to visualizations. You can choose the file name that this is all written into, the directory, etc., etc., etc. So that was a deep dive into the Denote Explore package. I hope you found it useful. If you have any questions or comments, or you want to see some additional functionality or some changes, feel free to leave a comment at this video, or ideally raise an issue on GitHub. In the next video, we'll start looking in the production process of the Emacs Writing Studio workflow, which is where we're actually going to take all these ideas, our Denote digital garden, if you like, and harvest the ideas and create some wonderful pieces of written work. So I hope to see you in the next video.